Finding out how something works is usually a simple process. You read the books, you look up the various scientific effects involved, make some personal observations. Microwave ovens have been a consumer product since the 60s, yet information on how they work is scarce. Rumors abound, misinformation exists, and the ovens seem a little magic. One of the first PR problems that microwave ovens have is that we have to use the word radiation. Now, this is not atomic radiation. It's electromagnetic radiation. Electromagnetic waves have two related aspects, frequency and wavelength. The higher the frequency, the shorter the wavelength. You can study this relationship sometime yourself by taking a toilet plunger into the bathtub with you. As you wiggle the plunger faster, the ripples you make are closer together. Now, the wavelength there is due to the speed of ripples in water. Electromagnetic wavelengths are due to the speed of ripples in space. That's 186,286 miles per second, speed of light. This is a chart. I made it myself. It shows the range of electromagnetic radiation. At the bottom end of the spectrum are radio waves. As you move up the spectrum, that's higher frequency, there's heat. It's also a form of electromagnetic radiation. Move up in frequency some more, visible light. Beyond, ultraviolet, X-rays, and I don't know what. Now, the crew's already gone to sleep, so I'm not going to dwell too much longer here. Just notice that radio, heat, and light are all the same electromagnetic effect. And the boundaries on this chart are arbitrary. Things that give off light also give off heat. And if you've seen an infrared photograph, you know that heat can be focused with a camera lens. Microwave ovens operate in the radio portion of the spectrum. It's expanded here. The names of the various radio bands are cute. You know, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and I guess extremely high frequency. Now remember, the wavelengths get smaller as the frequency goes up. And with high, very high, ultra high, super, and extremely, the radio spectrum is rapidly running out of ridiculous superlatives. So somewhere about in here, we start to call them microwaves. Here's a fast tour. Here's the AM radio band. At the middle of the band, the frequency is 1 megahertz. That's 1 million cycles per second. The wavelength's about 935 feet. Here's TV channel 2, 54 million cycles per second, 218 inches. Here's the 2-meter band. Wavelength, 2 meters. That's about 80 inches. Frequency is about 150 million cycles per second. The C-band communication satellites, those are the ones we all watch, are sitting around 5 gigahertz. That's 5 billion cycles per second. Microwave ovens sit at 2.45 gigahertz. Wavelength, about 4.8 inches, 12 centimeters if you're newfangled. Now, the various radio waves travel differently. AM radio will reflect between the Earth and the ionosphere and go right around the Earth. Television signals act more like light. They disappear over the horizon in 30 miles or so. The microwave energy in ovens acts a lot like light. And has a further interesting property. It'll heat food. Now, microwave ovens heat mostly the liquid content of the food. That's why simple foods cook the best. Foods with wet and dry components mixed need special treatment. The microwave energy wiggles the molecules in the food directly, so the oven heats the food, not its container, or the air inside the oven. The wavelength of the energy is about 4.5 inches. Now, aluminum foil's okay in there for shielding a chicken's wing from cooking too fast. But you have to watch out for metal things like the metallic glazes on coffee mugs. Their diameter makes a darn good microwave antenna. Microwave ovens are extremely foolproof and safe, unless you do what I'm about to do. Now, you and I cannot disassemble a microwave oven and then use it again. This oven on top was provided by Sanyo with the complete understanding that we were going to take it apart. They're going to reassemble it and test it. Here's the source of microwaves. It's a strange cousin of the vacuum tube called a magnetron. My online encyclopedia came up with an excellent description of the magnetron, but the crew only allows me one physics lesson a day, so you're going to have to look up magnetron in your own encyclopedia. The oven proper, just a metal box that won't allow microwaves to escape. A fan over here blows air across the magnetron to cool it, and then that airstream is directed into the box and out of vents at the back. The airflow in the box does more than just remove the moisture from the heating food. It also runs the stirrer. Microwaves travel like light, and the stirrer fan is sort of like a mirror ball above a dance floor. It distributes the microwaves all over the box. Now, the great demonstration. I'm going to substitute a light bulb for the magnetron. That way you can get a glimpse of what the food feels. I had to put this box around it so that the airflow wouldn't get disturbed. It's a puzzle. It's a good puzzle. Now, the heating effect depends on the moisture content and the density of the food, so it's incorrect to say that they cook from the inside out. Anyone who's ever blasted a frozen pound of hamburger on high will attest to that fact. There really are no power levels in the microwave oven. The magnetron's either on or off. Setting the power level actually sets how long the magnetron will be on or off. This is half power. The magnetron's on half the time. At full power, the magnetron's on all the time. Cycling on and off is important to even heating, because with some foods, the magnetron will heat hot spots. The off time lets those hot spots heat the cooler spots. This is defrost timing. It's on pretty seldom, so that the warmth has a chance to thaw the interior of a lump without cooking the exterior. Now, my light bulb substitution isn't quite perfect. I couldn't quite mount the bulb exactly where the magnetron emits, and the fan and the interior of the box don't reflect light with the same efficiency that they reflect microwaves. Microwave distribution is much better. There is one classic dead spot inside every microwave oven I've tried. It's in the middle, right under the stirrer fan. Of course, right after the show, you'll probably read the instruction book that came with yours 3 years ago, huh? Coffee? Oh, in the next episode, we're going to look at sugar, butter, and milk.